Hi everyone, welcome to Trigonometry. Today we explore lesson 5, inverse trigonometry. Number 1, inverse sine, cosine, tangent. If we look at the graph of sine, we see that there's a section from negative pi over 2 to pi over 2 of the graph. That is 1 to 1. So if we use this section, then we can get the inverse of sine. And the inverse of sine is y equals sine to the negative 1x, or we can call it arc sine of x. The range of the arc sine is between negative pi over 2 and pi over 2. For the cosine function, cosine is 1 to 1 for the interval from 0 to pi. And if we use that interval, then cosine has an inverse. And we call that inverse arc cosine. The range is between 0 and pi. For the tangent, it has many repetitions, and we only used one repetition. So if you look at the tangent for the angle between negative pi over 2 and pi over 2, well, tangent is 1 to 1. Of course, it has an inverse, and we call the inverse of tangent arc tangent. And the range of arc tangent is between negative pi 2 and pi over 2. These are very useful number. Range of sine, cosine, arc tangent. Let's take a look at some example. Number 2, examples involving number. Let's evaluate a tangent of arc sine 1 over 2. Well, we know arc sine 1 over 2 is an angle. So that 1 over 2 is exactly sine of that angle. And let's be careful there. The angle here has to be between negative pi over 2 and pi over 2. There's an angle. So the sine of that angle is exactly a half. And that is pi over 6. So we know sine of pi is 1 over 2. Therefore, the angle is pi over 6. Okay. And then from there, we just have to figure out tangent of pi over 6. Tangent of pi over 6 is root 3 over 3. B, or cosine of sine of 5 pi over 3. That is, or cosine sine 5 pi over 3 is negative root 3 over 2 because 5 pi over 3 is in quadrant 4 and sine of an angle in quadrant 4 is negative. Okay, so what we know here is that our cosine is an angle theta, and cosine of that angle is negative root 3 over 2, where the angle theta has to be between 0 and pi. Now cosine of what angle is negative root 3 over 2? Well, that would be an angle that is in the second quadrant. And that angle is pi over 6, negative root 3 over 2. From here, the angle theta is 5 pi over 6, and this is the answer. Yeah, be careful. Okay, let's move on to number 3. Examples involving variables. These are very useful in integration, calculus 2. Find a cotangent of arc sine x over 2. There must be an angle theta equal to arc sine x over 2. Sine of that angle theta is x over 2. Well, we know the angles defined inside the right triangle. This is the angle theta. Sine is opposite over hypotenuse, so the opposite is x, hypotenuse 2. And then from there, using the Pythagorean theorem, the adjacent side is c. C squared plus x squared is 2 squared. C squared is 4 minus x squared, so c is root of 4 minus x squared. And once we have all the side of the right triangle, then cotangent of the angle is one over tangent, which is adjacent over opposite, and that is root 4 minus x squared over x. Let's take a look at another example. B, cosine of arctangent 2x. Similarly, there must be some angle theta such that that angle is exactly arctangent of 2x. So tangent of the angle theta is 2x. 2x is the same as 2x over 1. So 2x is opposite, 1 is adjacent. And then from there, we can sketch out the right triangle with the angle theta. Opposite is 2x, adjacent is 1. We can use the Pythagorean theorem to figure out the hypotenuse h. Using the theorem, h squared is 1 square plus 2x square. H squared is 1 plus 4x square. So h is root of 1 plus 4x square. Now cosine of the angle theta is, from the definition, adjacent over hypotenuse, which is 1 over root of 1 plus 4x squared. Thank you for watching. I hope you find the content useful. Please like, subscribe, help the channel.